Good afternoon, ladies and gentlemen. My name is Zurab Brodzeli, and today I'm presenting PhoenixZ with its intrinsically safe optical telemetry system. Outline of my talk: I'll present the company, I'll present myself, CEO, then board of directors, intellectual property that company owns. Then we'll talk a little bit more about core technology. Then we'll represent how this core technology is used in our product. We'll talk about the product, business opportunity, market, competition, product itself, its price, and then we'll introduce to you progress done today and opportunities. Well, first of all, Phoenix. Company was created 2021. Zurab Brodzeli, I'm CEO. Company owns its own IP, which is protected in 3 jurisdictions: US, Australia, and China. Fund raised in June 2024, $750,000. Board consists of 3 directors, and it's fully owned Australian company. Well, Zurab Brodzeli, myself. Well, my education is, I got bachelor's degree in 1989 from Tbilisi State University in Georgia in quantum electronics and laser physics. Then I got my master's at General Institute of Physics 1991 in Moscow, specializing in electro-optics, optical modulators and liquid crystals. Then I've got PhD from Sydney University in 2001, specializing in photonics, fiber optics, fiber optic components, and fiber break gratings. I've got my business studies in 2007 at AGSM, specializing in marketing and management. Now, my expertise, my work experience, well, quite extensive. From 95 till 98, I worked at Sydney Uni UNSW as professional assistant and PhD student. From 98 till 2000, I worked as R&D manager at Redfern Optical Components. I'd like to mention that this company was created based on patent where I was co-author. Then I went to the States, and from 2000 till 2002 worked at Failsafe Communications, where I had the same role as Redfern Optical Components, R&D manager. From 2003 till 2012 I worked at various universities as a consultant and a research fellow. It's UNSW, University of Sydney, and Victoria University. In 2010, I was consulting Thales Underwater Systems. In 2012, I started a company called ZLF, where I was co-founder and worked there till 2021 as a CTO. In 2021, I created a company called PhoenixZ, where my capacity is CEO. I hold few patents. The most important patent is optically based voltage sensing device and method. This patent actually is protected in 3 jurisdictions, and I'll talk about it a bit more in a couple of seconds. Now, IP ownership. As I mentioned before, PhoenixZ owns its own IP. It's called optically based voltage sensing device and method. We call this device, it's a particular device that we call fiber optic transducer. Examples of use of this transducer in the patent are sensing underwater and sensing underground for hydrophones and gas detection. And this device is protected in 3 jurisdictions: USA, China, and Australia. Now, board of directors. Board consists of 3 members, 3 directors. Dr. Zurab Brodzeli, I'm Australian. I'm CEO and chairman. I'm founder and creator of technology. My expertise are in photonics, business, marketing, startups. Dr. Adrian Carter, he is Australian as well. He is the director, advisor, and he is investor. His expertise is in photonics, business, marketing, sales, startups, and large organizations. Adrian was CTO of one of the world's largest photonics manufacturing company called Coherent. This company manufactures lots of almost all range of optical components, starting from optical fiber, ending up with expensive lasing systems. He was involved with Delphi lasers. He was creator and founder of Redfern Fibers, and now he's involved with Newtown Technologies as well as Phoenix. Dr. Eugene Zhao, he is director, advisor, and investor. His expertise is in photonics, marketing, sales, startups, and large organizations. He's involved with Delphi lasers and linear lasers. Well, core technology. Core technology, as I mentioned before, is fiber optic transducer. That's a device that transforms electrical signal into optical with no power required. This is a unique proposition. Nobody in the world can do this. Only Phoenix can do it and owns this technology. Dynamic range of this transducer is quite high. It's 100 dB. It can sense 10 microvolts up to 3 volts. Bandwidth is 5 kilohertz. It is a linear device. Total harmonic distortion is 35 dB. And this particular package is rated for 2,000 meters underwater. This package was developed for underwater applications. I personally was testing it. How it works? It is actually quite simple device. It's a variable reflector mirror. Here we can see that light irradiates gold mirror. Light is supplied to gold mirror using optical fiber, via optical fiber, and there is a liquid crystal between optical fiber and gold mirror. When there is no voltage applied to liquid crystal, all the light that enters the fiber transmits through liquid crystal and reflects from fiber, transmits again, and it's out. As soon as we apply voltage to liquid crystal, it changes its optical properties, and light doesn't transmit through liquid crystal anymore and doesn't reflect from the mirror. But how it is used in the system, how this transducer is used, here it is. We have light source that generates light and launches it into port 1 of the optical circulator. Optical circulator is a standard fiber optic component, 3-port fiber optic component. Circulator circulates it to port 2, connected to our electro-optic transducer. Our transducer is connected to sensor. As soon as environment around sensor changes its electrical output that is applied to our transducer. Our transducer changes its reflectivity that is monitored by light. It reflects more or less light that is launched back into circulator, and circulator circulates it back into its port 3, connected to photodetector. Photodetector transforms this light into electrical signal and hands it over to digital analog acquisition card that is connected to the computer. And now we can see output of the sensor on the screen of our computer. But that's all cool if transducers do not require any power. And there are materials, and there are, oh sorry, not transducers, but sensors don't require any power. And there are materials and sensors that do not require power. They are based on piezo materials. They're used for measuring vibrations, accelerations, pressure, used to detect sound waves underwater in hydrophones, but not all of the sensors like this. Usually sensors require power. Not much, few microwatts, but they do. So how we get around it? Well, first of all, I would like to mention that due to its electrical properties, transducer can be used for sensing applications. Its bandwidth does not allow it to be used to transmit video signals, because video signals require high frequency, gigahertz, megahertz of the changing signal. And our transducer supports kilohertz. Its bandwidth, as I mentioned before, is 5 kilohertz. So preferred application is sensing. Now, optical connectivity, it enables optical connectivity of the sensors to fiber optic networks, where users can fully enjoy all advantages of fiber optic networks. Its bandwidth, intrinsically safe, not sensitive to electromagnetic interference, multiplexing capabilities. Now, the transducer doesn't require any power, meaning that the sensor with the communication device inside does not require power for communication, and that's the major use of power in the sensors with the communication devices. It enables us powering the sensor using only light, and that enables us creating all fiber optic sensing networks, which is very, very important and makes the network intrinsically safe. Why it's intrinsically safe? Because the conventional networks are based on copper wires, and the signal is carried by electrical signal. The data is carried by electrical signal and power as well. So what happens when this kind of copper wire, copper cable is cut? It can spark, and sparks ignite explosions, and explosions can kill people. In case of optical fiber, even if the optical fiber is cut due to some accident, spark doesn't happen, so there is no explosion and lives are saved. The fact that it is all optical and the coverage range is quite large, it doesn't require any infrastructure. Infrastructure, I mean uninterrupted power supplies, various switches, interrupters, routers, and it's a big deal because all this equipment is expensive and requires service. And as I mentioned before, our network can have large coverage area, up to 50 kilometers. So what's the applications? Where can it be used? First of all, we need to consider 3 points. It can be used wherever wireless cannot. It can be used where power is not easily available. It can be used where electrical signals are hazardous. So it leads us to 2 major applications. One is areas, flammable or explosive areas, environments, and another is underwater. There is no power easily available underwater. So it means that it can be used in sensing networks for underground coal mines. Of course, there are other applications as well. It can be used at hydrogen generating plants. It can be used in sugar mills and other, but we decided to go for underground coal mines. and it can be used sensing networks for underwater. I would like to mention that we investigated both applications. It demonstrated excellent capabilities because not too much competition is available, because usually all the technologies are based on either copper wires or even if it's fiber optic, they require power. Ours do not. But due to historical reasons, we decided that the lowest hanging fruit for commercialization is underground coal mines. So we decided to investigate possibility of commercialization of fiber optic networks for monitoring methane, oxygen, carbon dioxide, and carbon monoxide. To start commercialization, the first task is to estimate the markets. Does it exist, and how much is it? So we investigated, of course, national market, which is the closest, and two biggest markets, USA and China. In Australia, there are 31 active underground mines with overall market size 37 million. USA is 234 mines with overall market 279, and in China 3,219 with huge $4 billion. My face actually covers this exciting number. Who are the customers of our technology? The customers are mines, mine owners, and companies that manage operations of these mines. Here is the list of mines in Queensland, and of course in Australia, biggest mining companies are Glencore, BHP, Young Coal Australia. So that's who will be going for. Competition, and we investigated our competition, who we'll have to fight with. There are a few companies. There is a Chinese company which is the biggest. It's called Hanwei Electronics. Its revenue is 315. Then there are three Australian companies: M-Control, Nautitech, and Mine ARC. M-Control is the largest. It's listed at the stock exchange. Its revenue is 211 million. Then there is an American company called Matrix Design Group, and a British company Edinburgh Sensors. We studied all of the products of these companies, and it turned out that all of them require infrastructure, require support. They require UPSs and other infrastructure, and using other electronic equipment in coal mines means that there are more possibility of failure. Not mentioning that all these networks are based on hazards, on electrical signals, and all this equipment is hazard as well. Additionally, all this equipment costs money, and it requires very regular service. So, and potentially, if there is an interruption of power in the mine due to billions of different reasons, the system stops working, and mine management stops receiving extremely important information about dangerous gases. In contrary, our system doesn't have all these problems. First of all, our network doesn't require any UPSs or any supportive equipment. Secondly, which makes it safer and cheaper. Secondly, its coverage area is large without need for this supportive equipment, tens of kilometers. And it's so-called Failsafe operation. So because it doesn't require any support, even if there is an interruption in the whole mine or in the part of the mine, our network works and delivers important information to the management of the company, operation management of the company, which is very important. And with this, I am moving to our specific product where this technology is used. We call it, have a lucky guess, CANARY-2000. Guess why? Well, here's a small animation of how it works. So it has gas monitoring RTU, return terminal unit, and gas monitoring station. RTU is in safe environment of the safe. Now RTU generates light that goes via circulator to gas monitoring station, where it's split. Part of it goes to our transducer and part of it goes to power converter that feeds sensors with energy, and then sensors feed electrical signal to our transducer that reflects signal to photodetector, and from photodetector it goes to data acquisition card that transforms the signals to required protocol. In our case, it is Ethernet. We suggest star configuration where each gas monitoring station is connected to our RTU, return terminal unit, by fiber optic, ruggedized fiber optic cable, and this RTU is placed outside the explosive area in a control room, is connected to a local network or to wireless router. This slide actually compares our CANARY-2000, our system, our product, to standard Ethernet-based networks. Internet-based networks use so-called Ethernet over power. That's how they power their sensors, gas stations. And as we can see, the system, Ethernet-based networks are quite complicated and require support infrastructure, intrinsically safe, uninterrupted power supplies, industrial computers, routers, remote tripping switches, as well as network is copper-based, and network itself is hazardous. All these UPSs, they can fail. So it is much more complicated than ours compared to ours. In our case, in case of CANARY-2000, there is no infrastructure, only ruggedized fiber optic cables. I would like to mention that mine is like living organism. It always changes its configuration because miners develop code and they move forward. And it's very useful to move gas stations along with the miners. But in case of Ethernet-based networks, it's quite complicated. You need to move UPSs and all infrastructure with the gas stations. It's possible, people fly to the moon, but it's expensive and, as I say, complicated, and it's hazardous. In our case, there is our gas monitoring station is very light. It's 1+ kilograms. It can be easily moved and to different locations of the mine. Now, here's our offer. You can see here is RTU based on modular approach. Depending upon how many stations, gas monitoring stations are required, we can slot different number of modules, and here is IP rated gas monitoring station. Now the price of RTU is 2,500. Chassis, price of the chassis, gas monitoring station is 22,000. Training is 2,000 because as soon as customer acquires our product, one of our engineers will visit mine site and train miners how to install, how to look after our equipment, and how to operate it. Calibration cups required to calibrate gas monitoring stations are free, and we offer 1-year product support.